Hi, my name is Dan. It's a pleasure to be here. The main development language right now for the Oniro platform and for Open Harmony is a fork of JavaScript, of actually more precisely of TypeScript called ArkTS. And one thing that was kind of missing from the picture right now was an application level programming language on the lines of, let's say, Java or Kotlin or Swift. And that programming language is called Cangjie. It has been under development for quite a few years, but it has been open sourced last year. So you can try it out for yourself. It doesn't have, like, right now, it's not formally included into this Oniro distribution, but that's hopefully something that it will be happening anytime now. So this programming language has been developed mainly by people at Huawei. And the reason why it's good to have your own programming language is the same reason that, for example, Apple has its own programming language, Swift. And that is not just because you think, oh, I'm going to make a programming language that's like unlike anything the world has seen so far, but because a programming language is a glue that binds together your software stack to your hardware. And Huawei is like Apple is a very vertically integrated company that makes everything from silicon all the way to consumer apps. And again, the latest kind of addition to this ecosystem, to this full stack, was an application-level programming language. So an application-level programming language does not mean just a language itself, but the entire ecosystem of tools that's needed to support that programming language. So I have been part of that team based in Edinburgh, but there are many teams that work on this project. The main team is in Hangzhou in China, but also in Shanghai and in other research centers in China. The name Cangjie comes from this mythical character who is the inventor of the Chinese script. And it's not very easy to pronounce in English, so sometimes we refer to the Cangjie language as CJ, which sounds a little bit more palatable to people who speak English, and also it matches the file extension when you write such a program. So the language has been developed by Huawei, but it's now open source. It is general purpose. It is high level, expressive, safe, quite similar to other languages in these brackets, such as Kotlin, Java, or Swift. Statically typed, which means it's both safe and it can be efficiently compiled, unlike languages which use dynamic typing, such as JavaScript or even TypeScript, because TypeScript, even though it has statical typing, it retains some dynamic aspects that make static compilation a challenge. It is type and memory safe, so you shouldn't have memory leaks, you shouldn't have null pointer exceptions and stuff like that. If you have them, usually it means there's a bug somewhere, but they shouldn't happen by construction. It is garbage collected, and it has a concurrent garbage collector. It has a full-fledged garbage collector, unlike languages such as Swift, which use like reference counts. So this is like a full-blown concurrent garbage collector, which has good level of performance. And it has several backends, so you can write the program and then compile it on Linux. You can compile it on Mac OS, Windows, HarmonyOS. So you can already compile it on pretty much all the devices that you have seen so far. And those are the links where you can access it if you want to just have a go at it, see how it feels. Right, so as I said, there's a lot of work in developing a programming language, because a programming language is not just the compiler. There's a lot of stuff that you have to do. You have to develop frameworks to be able to produce apps like UI frameworks, testing frameworks, and so on. Language SDKs, APIs for interfacing with the operating system, which actually HarmonyOS has tens of thousands of functions in the API, so all that has to be supported. Tools for testing, for benchmarking, for test covering, debugging, and so on. All that has been developed. Obviously it's not a mature ecosystem because it's only been made open source last year, but it covers already the breadth of what you would expect a mature programming language to cover. And also you have to produce the runtime and the standard library to interface with the operating system. Yeah, so all that infrastructure is in place, and you can write serious programming, serious apps with it, and there are already quite a few apps developed in the HarmonyOS Next ecosystem using Cangjie. Probably our most successful partnership is with Meituan. Meituan is a big company in China that does deliveries, and their app is now mostly on HarmonyOS Next, is mostly written in Cangjie. In China, there is also a very vibrant ecosystem that involves universities, teaching, and the open source community. There are a lot of open source projects for Cangjie. Many universities, more than 80 universities, are either using it as a teaching language or they're planning to use it as a teaching language. So just like with Open Harmony, the ecosystem in China is very robust, and it is in some sense enough to guarantee the long-term viability of the language. Because one of the things that worries people the most when they commit to a programming language is like, will this language that I'm committing to, will it be around next year, in 5 years, in 10 years? And this language will be around. It's already quite established, even though new, in a very large market. So here is a like-for-like comparison of our language with other language in the same bracket. And because we are kind of new to the party, we could just pick and choose the best features from other programming languages. We are, at the time, unburdened by legacy considerations, by existing customer consideration. We could really put in everything that we thought would be good to have in a programming language. So we have algebraic data types. I quite like the support for algebraic data types in Cangjie. What are the things there that are let's say quite nice to have? Well, we have very strong macro facilities. There's a lot of effort that was invested to have very flexible support for macros. I'm not a big fan of meta-programming myself, but people who like that, go and use it. What I am a fan of, and I'm going to talk a little bit more, is this thing at the bottom called effect handlers. Other than you, who has heard of effect handlers? So effect handlers, we are very, very happy to be able to include effect handlers into the Cangjie programming language, because you can see that is one point of distinction between Cangjie and other similar programming language. So that was, in case you haven't seen algebraic data types, if you are if your predicament is to be a Java programmer or a Go programmer, they look very nice. They look like this. So you can do on complex data types such as trees, you can do pattern matching, which is tested by the compiler for coverage, so that it's exhaustive and complete. So that for exhaustiveness. So you can write structurally inductive programs just like, or structurally recursive programs just like you would do in OCaml or Haskell or other functional programming language. Very elegant. But what I want to talk a little bit more, because that is more likely that you haven't seen, is effect handlers. So effect handlers have been researched very intensely by the programming language community in the last 10 to 15 years. There's a lot of papers. Luckily, or maybe not so luckily, maybe that was kind of the reason why I was influenced, is that they originated in Edinburgh, and probably you were around at the time of their genesis. And they have been kind of the motivation behind effect handlers was to add a ways for pure functional programming languages to interact with the world and to interact with their context. Before effect handlers, the standard way of interacting with the world or with the context of a functional programming language was via monads. Who knows about monads? Who has heard of monads, the word monads? No? Okay. Monads have somehow they're like a very big feature, a very big thing, particularly in Haskell. And they have kind of, people like to love them or hate them, but in fact they have some technical shortcomings that I'm not going to get into it, and effect handlers were intended as a way to overcome that the limitation of monads. And they did, but in the process, like, okay, doing all these kind of theoretically driven development, in the end they invented something which is a new programming language feature that many people, including myself, asked, would this feature be useful not just in a functional programming language, but in any programming language that already has other ways of interacting with the environment? And the answer is yes. So one way to understand effect handlers very quickly is that they are a generalization, or the way they're presented is a generalization of the concept of exception. So here on the left, you have a concept of exception, which is the standard concept as seen in many languages, where something bad happened, in that case, an attempted division by 0, and then you throw an exception. People say it's called a throw an exception because it goes up your call stack into the context. You expect the context to somehow deal with it. So you throw it into the context. It's going to be caught by some handler which is up in the context, and then the only thing that the handler can do with a normal exception is to find a way to exit that error situation gracefully, clean up and exit. Now, effect handlers are different because they give the context the ability to actually deal with that problem, deal with that situation, and then continue as if nothing happened. So you see here at the bottom, there's a new keyword that says resume with something. So if I find a division by 0 in that particular context, I can decide it's not catastrophic. I know it's not correct, but I can just return 0 and I can carry on. Maybe there's Maybe there's a function that is computing your next favorite song by Spotify, and you would rather get an imperfect song rather than the whole app crashing. So, that's the kind of situation where it's okay to just make up a number and carry on. So that's the key distinction, is that an effect, it allows you to resume an exceptional situation. And because it allows you to do that, it allows the programming language to revisit completely the concept of dynamic binding. Most of the coding that we like to do using conventional programming languages is to use static binding. So you have some code, and you want to perform some functionality, you call a function. So that means you go down into a deeper context. And then you perform some operation, and then that operation is going to give you some value. And that you can do it both for the purpose of computation, but also for the purpose of interacting with the system via foreign functions, like printing and stuff like that, that access your machine. But sometimes the context is not known. Like you don't know, so like an example that I just gave you, you don't know you don't know what the context is. So if I make a division and I get division by 0, now whether I kind of fly the space shuttle or whether I'm performing my next favorite Spotify song, these are very different contexts. And my approach to what should happen if this illegal circumstance arises is going to be very different. That can only happen if I throw that error, or if I send that error up to the context to deal with it. And that is what essentially dynamic binding is. So dynamic binding in conventional programming languages is, instead of calling a function, which means go down, you ask the context, which is up in the calling stack, to deal with it. And this is actually there's a lot of dynamic binding frameworks, because you cannot basically do a dynamic binding library just by definition. The libraries are always go down into the stack, whereas you want to go up into the call stack. And the dynamic binding libraries that you find for Java and so on, they tend to be quite big, quite monolithic, kind of over-engineered, because the language does not have native support. So they end up using bunch of metaprogramming, reflection, ways to get around the fact that the native support does not exist. But with effect handlers, you have this ability. So for example, the hello world of dynamic binding is logging, right? You wanna have a framework where you log things. But the concept of logging is very loosely specified. So imagine that you write a library for a framework such as Oniro. So that library can run on a laptop, on a mobile phone, on a watch, on some kind of IoT device that has, doesn't have a screen, or doesn't have a hard drive, or doesn't have a console. There's no standard way to do logging across all platforms. So then what do you do? Well, in that case, you need to use dynamic binding. Whenever your code needs to log something, then you need to inform the context, saying some logging needs to be done. And then the context will know how to handle the logging, but also, unlike an exception, you need to be able to come back. You don't want to just throw an exception and quit your execution. You want to perform that logging in a way which is controlled by the context, and then resume the computation. So for example, on a desktop here, you can see that you're performing some function, and that function performs a log. And in the handler, because I'm on a desktop, I have a console, so I can just print to the desktop. I can just print to the console. Whereas if I'm on a mobile, the mobile doesn't have a console, so then if you want to do the logging, maybe you decide to just open some kind of alert that presents that log. But also you could send it in an email. Or you could just ignore it. You can do whatever you want. The context can decide as appropriate. And that really is all that there is to it, to logging. You can do logging in 3 lines of code. Now try to do the same thing with the language without the fake handlers, and you will see that is significantly more complicated. Right, so we have some more worked out frameworks using fake handlers. One of them is for logging, but also there are other things that are a little bit more complicated, but I'm not going to go into too much technical exposition right now. But if you go to the library of kind of quasi-official third-party components, that's what TPC means, for Cangjie, you're going to find a few libraries using a fake handler there. And this is the end of my talk. Thank you very much. If you have any questions, let me know. Or also, Jarek didn't have time to take questions, so also if you have questions for him.